Why random variables? In theory, one could solve any discrete probability problems by enumeration, for example, using tree diagrams. The key advantage of random variables over pure enumeration is this. We can now replace probability of some event of interest by probability of some functions of x take some value. That is, we get to work with functions, we can visualize them, do algebraic manipulations, and work with multiple random variables at once. Example, let x be a randomly chosen integer between -10 and 10. What is the probability that x minus 1 times x plus 3 is bigger than 5? In theory, I could make a table of all possible values of x minus 1 times x plus 3, then check which ones are bigger than 5. With random variables, I can first manipulate the expression to something simpler. For example, after some algebra, then I find that x minus 1 times x plus 3 is bigger than 5, if and only if x minus 2 times x plus 4 is bigger than 0. This function is a parabola with roots at 2 and minus 4. It is positive whenever x is bigger than 2 or x is smaller than minus 4. So now I have the following problem. X in an integer chosen uniformly at random from -10 to 10. I need to compute what is the probability that x is bigger than 2 or x is less than -4. And here is where I do the counting. It's much easier compared to the original solution. Here's an exercise. Consider the quadratic equation with random coefficients. So that is ax squared plus bx plus c equals 0, where a, b, c are random. So now the question is, what is the probability that my quadratic equation has no real solution? This kind of problem is really common in physics and robotics. And now let a, b, c just be independent Bernoulli with probability a half. A Bernoulli p is just a binomial 1, p. That is, it is counting how many successes there are in one trial where the trial has success probability p. So in this example, it means a, b, c are independent. Each one has probability a half of being 1 and probability a half with being 0. So again, the problem is, what's the probability that my quadratic equation now has no real solution? Solution. We need to compute the discriminant, which is b squared minus 4ac. A quadratic has no real solution if and only if the discriminant is less than 0. Since a, b, and c can only take values 0 or 1, this expression is less than 0, strictly, if and only if a and c are both 1. So therefore, probability the quadratic has no real solution is the same as probability that a equals 1 and c equals 1, and this happened with probability a half times a half, which is a fourth. Let's quickly double check our work. So if a is 1, c is 1, when b is 0, I get x squared plus 1. There's no real solution. Otherwise, I get x squared plus x plus 1 equal to 0. That also has no real solution. If a is equal to 0, then it's a linear equation. I always get a solution. And if a is equal to 1, but c is equal to 0, then I get x squared either is equal to 0 or x squared plus x equal to 0, both of which have real solutions. So indeed, our solution is correct.